Hi, and welcome back to our series of lessons on surface area. I hope you remember what we did in the last lesson. If you don't, that's okay. I'm going to give you a quick reminder. We looked at what area is and the standard units of measurement we use to describe area. In this lesson, we're going to use two very important facts that we discovered in our last lesson. Firstly, that shapes made from the same parts have the same area. And secondly, the formula for calculating the area of a rectangle is area is equal to base multiplied by perpendicular height. By the end of this lesson, you should be able to find the area of a parallelogram and the triangle using the area of a rectangle. Take a careful look at this rectangle PQRS. It has a base SR and height QR. Do you think it would be possible to cut the rectangle somewhere and make it into a parallelogram? I'm going to show you something very clever. Have a look at this. Here's a cutout of our rectangle. Now I'm going to draw a line from this vertex to the base of this rectangle. Take your pen and ruler and mark off a line. The vertex to the base on the other side. Now take your pair of scissors and cut along this line. Now let's move this triangle to this side over here. I've made a new shape. Do you recognize the new shape I've made? Did you see that I have made a parallelogram? Let's have a look at this again using a graphic. So if I make a triangular cut from the point Q to the base SR, and I'll call this point B, we have a triangle that we can move across to side PS. Pretty clever, hey? But will this work with any rectangle? Will this part of the rectangle, QR, always fit on this part of the rectangle, PS? Yes, it will. The opposite sides of a rectangle are equal and parallel, so we can mark that PS is equal to QR. Now PS and QR also represents the height of the rectangle. Let's label our new diagram. We'll call it P, Q, B, and B prime. Let's look at our rectangle PQRS and parallelogram PQB, B prime together. Will they have the same area? Yes, of course they will. We know that we have used the same pieces that made up the rectangle to make up the parallelogram, so the areas must be the same. Great. So what is the formula for the area of a parallelogram? Let's see. The formula for the area of a rectangle is area is equal to the base times the height. The area of the parallelogram should be the same. Let's check. Can you see that the base has not changed? All we did was to move this piece of it, RB, to the other side. The height of the rectangle also hasn't changed. So the area of the parallelogram is area is equal to base times the height, where the height is the perpendicular distance between the parallel sides PQ and B prime. Why don't we see what other shapes we can make from the rectangle? Do you think that we can change a triangle into a rectangle? Have a look here. Here's a cardboard cutout of a triangle. Why don't you make your own cardboard triangle and follow along with me? I'm going to fold this vertex onto the base like this, so that I can find the midpoint of the sides of the triangle. I'll use my marker to mark the line where the midpoints are joined, and I'll use a pair of scissors to cut along this line. I'll use the height mark as a guide to cut along here as well. I now rotate the triangle like this and rotate this triangle like this. Let's look at that again. Did you get it? Let's use a diagram to show you what we did. Let's call this triangle MPO with height H. We found the midpoints of the two sides of the triangle by folding. We label them Q, N, and join the line. I'm also going to label this point here S, where the perpendicular meets the line QN. Can you see another two triangles inside this new triangle that I've made? They are triangle MSQ and triangle MSN. We cut out the triangles. Then we rotated triangle MSQ around point Q, and then rotated triangle MSN around point N. And so we created a rectangle like this. Do you see that this point S has actually become the vertex of this rectangle and has moved to create this point over here as well? So we have got the rectangle SPOS prime. We already know the formula for calculating the area of a rectangle. It is the base times the perpendicular height. Let's look at this changing of the triangle into a rectangle carefully again and see if you can work out the formula of the triangle. We have kept the base of this triangle, PO, the same in this rectangle. We know that the area of a rectangle is area is equal to base times, and I'm going to call the height of this rectangle capital H. Now, when we found this rectangle, all we did was move pieces of the triangle to make this rectangle. So we can instead say that the area is equal to the base times, now the height of this side was half the height of the original triangle. So we can write this height as half small h. So the area of this triangle is area is equal to base times half of this height. You may have learned a formula for the area of a triangle already. Do you remember being told that area of a triangle is half the base times the perpendicular height? Well, that formula is the same as the one we just found by cutting the triangle to make the rectangle. Here, though, we found that it can also be written as base times half the height. Algebraically, both formulae are the same. In this lesson, we found the formulae for the parallelogram and triangle. We did this by making the parallelogram and triangle out of the rectangular shape. We used the formula of the area of the rectangle to create the new formulae. Right, now it's your turn to do some work on your own. See if you can make a triangle from a cutout of a trapezium. If you can do this, then you can find the formula for the area of a trapezium. That's all for now. Till next time, goodbye.